5.3, adding and subtracting radical expressions. This begins on page 163. We're going to start on question 1. Fill in the blanks to make the statement true. When you are adding and subtracting radical expressions, you need to make sure it's the same type of root and the stuff inside the root is the same. When you are adding and subtracting algebraic expressions, let's say we have 5x plus 3x. The 5x and the 3x are the like terms because they both have x. So you can add them together and it becomes 8x. If we have 5x plus 3y, those are not like terms, and so you can't add them together. It just becomes 5x plus 3y. Very similar for radical expressions. If we have 5 root 3 plus 3 root 3, because it is the same radicand and the same index, so these are the same type of root, the same thing inside the root, that means it's like the variable x. Our answer is going to have that. So in this case, root 3, 5 plus 3 is 8, so you can add them together. If it is something different, then you can't add them together. Let's go do question number 1. Fill in the blanks to make the statement true. Like radicals have the same radicand and index. Like terms have the same variable and exponent. So when we're adding and subtracting in algebra, we call those terms. And in this case, for the radicals, we need to have the same radicand and index. C, the radicals root 12 and the square root of 27 can be simplified so they are like radicals. Let's just check that one out. So the root of 12, and we need to look at root 27. Right now they don't look like they are like radicals, but let's see if we can reduce it. 12 is the same as 4 times 3. Root of 4 is 2, so this will be 2 root 3. 27 square root, so we need, I guess, basically a 9 times 3, so that's going to be 3 root 3. Yes, so they are like radicals because they both have a square root. Inside the square root is a 3. Question 2. Indicate whether the expressions are like radicals. Let's do 2D. 5 square root x squared plus y and 2 square root x y squared. Okay, well, let's simplify this. Square root of x squared is x. All right, let's simplify this one. We have a square root of y squared. Okay, same type of root, so they're both square roots, but the stuff inside the root is different, and so they are not like radicals. 4, complete each solution. These I always find challenging because you're trying to figure out how somebody else is thinking. So let's go through this one together. 5 root 20 minus 2 root 125 equals 5. Ooh, 4 times. So this was 20. So 4 times 5 equals 20. There's the 2. 25 times 5 equals 125. 5 times, okay, let's see, that 5 stayed. The square root of 4 is 2. Minus 2 times the square root of 25 is 5. Are these like terms? They are. Okay, well, let's simplify in the front first. 5 times 2 is 10. Negative 2 times 5 is negative 10. They are like terms. They're both root 5, square root of 5. 10 minus 10 is 0. 5a. Simplify each expression. So remember, our first step, we have to make sure they are like radicals. If there aren't like radicals, try to make them into like radicals. And if you can do that, then now you can add or subtract. Kind of like with the like terms for algebra or the same denominator for fractions. Okay, so in this case, they both have a square root, and inside the square root is 2, so those are the same. We can now add. 6 plus 3 is 9, and we just copy down the root 2. 5i, 4 root 12 plus 2 root 27 minus 3 root 75. Remember, first thing is, do they have like radicals in this case? No. We have 12, 27, 30, 75. They're all square roots. So let's see if we can make them into like radicals. 12, well that's 4 times 3. 27 is 9 times 3. I'm noticing everything has a 3 in it. I wonder if we can go 3 times something is 75. 25 times 3 is 75. Okay, the square root of 4 is 2, so I have 4 times 2. Square root of 9 is 3. Square root of 25 is 5. Left with a 3. Okay, let's just simplify this a little bit more. And they all have square root 3, so we can put them together. So 8 plus 6 minus 15 is negative 1. So negative root 3. 5p fraction. 2/3 root 12 minus 5/2 root 48 plus 1/4 root 108. They're all square roots. Let's see if we can make them into like radicals. (48) is 16 times 3. They all have 3 in them. Let's see if I can get a 3, or 108 divided by 3 is 36. So that's a perfect square. That's nice. Square root of 4 is 2. Square root of 16 is 4. Square root of 36 is 6. They all have root 3, so I can add them up. I just want to simplify a little bit first. 2 times 2 is 4, so this is 4/3. 5 times 4 is 20. 6 times 1 is 6. Okay, so we can add these together, so our answer will be something root 3. We have fractions though, so we have fraction rules to think about. So we have 4/3 minus 20 over 2 is 10 plus 6 over 4. Let's reduce that. That would be 3 over 2. Okay, it looks like a common denominator will probably be a 6. So for the first fraction, times the top and bottom by 2. Second fraction times the top and bottom by 6. Third fraction times the top and bottom by 3. That will be giving me a negative 43. So I have negative 43 over 6 and still have root 3. 6. Simplify each expression. All variables represent positive numbers, so we don't have to worry about using absolute value signs or having a negative number under the radical. 6d. Square root of 9x cubed minus the square root of 25x cubed plus x square root 16x. Okay, well let's first find our like radical. If I look here, I have an x, so it looks like I'm looking for an x inside the root. 16 is a perfect square, so that I'm going to simplify. Let's start at the beginning though. So the square root of 9 is 3. The square root of x cubed, well, I do the square root of x squared, and then I have a leftover x. Square root of 25 is 5. Square root of x cubed, well, x squared times x, right? So x root x, and then plus x. Square root of 16 is 4, and I have a root x left inside the root. They all have a root x, so now I have 3x minus 5x plus 4x. Add those together. They do all have x's, so we can add them together. So now like terms apply. That'd be 2x. So my answer is 2x square root x. Remember the order that you do things in? You have to first find your like radicals, and then second you can add or subtract. Now when you're adding and subtracting, if there are fractions, you still have to follow your fractions rules. If it's just algebra, you still have to follow your like terms rules. Those rules still apply. 6L, square root of 9y plus 27 plus y plus 3. Remember, our first rule is like radicals. It is tempting, but no, you can't. Let's split this up like so. That does not work. It has to stay as a group underneath the radical sign. But we can factor what's underneath there. So let's factor a 9 out of 9y plus 27, so that makes it y plus 3. Again, we're still looking for like radicals. And if I look here, I have a y plus 3. I'm just going to put brackets around there. Y plus 3 underneath both radicals. That looks interesting. Square root of 9 is 3. Now we have the same thing under the same type of radical. So y plus 3, we can add them together. So our second step is to add, subtract. Our answer is going to have a square root y plus 3 in it. 3 plus 1 equals 4. So it's 4 square root y plus 3. 7L. Simplify each expression. All variables represent positive numbers. Excellent, we don't have to worry about absolute value, hopefully. Cubed root x to the 5th divided by 8 plus 5x times the cubed root of x squared divided by 4. All right, let's see if I can find some like radicals. I'm looking here, x to the 4th. I can't make that any smaller, simplify that. So is there a way to change this into the cubed root of x to the 4th? They're both cubed roots. That part checks. The stuff inside needs to be the same. So let's look at cubed root of x to the 5th. And yes, we can simplify. The cubed root of x cubed is x. Let's just rewrite this. All right, so we can add the radicals together. We have fractions. So now we have the denominators to be the same. We have an 8 and a 4. Lowest common denominator would be 8. So let's multiply this by 2 over 2. So we have x cubed root of x squared. 5 times 2 is 10. Now we can add them together. So we have x plus 10x. Are those like terms? Yes, they both have an x in it, so that makes it 11x. 7r, cubed root of 8x squared y plus the 6th root of 64x to the 6th y squared. Ooh, we have a cubed root and a 6th root. That's interesting. We might not be able to fully simplify it because those are two different roots, but let's see what we can do. Okay, so let's rewrite this. to write it as exponents this time. 64th is the same as 2 to the 6th. Okay, so we have a group of 3. So the cubed root of 2 cubed is 2. Cubed root of x cubed is x. And I have the cubed root of y. Sixth root of 2 to the 6th is 2. Sixth root of x sixth is x. Sixth root of y, can't do much there. Okay, it's simplified. It's simpler, but I'm not certain if we're finished yet. Let's write this as exponents. So 2xy to the 1/3 plus 2xy to the 2/6. Oh, look at this. We can simplify that fraction, 2/6. Two over 6 is the same as 1/3. Now we have the same exponents with the same radicals. We can add them together. 2 plus 2 is 4. Let's rewrite this in terms of a radical. 8, find the perimeter. Going to do 8f, which looks like a parallelogram. I forgot to write down that those sides are equal. Okay. Perimeter equals the sum of all sides. Okay, so we know this side here is root 8, and we know this side here is root 32. Guess we have to find the two angled sides. You can see there's a box in the middle here. So this side here would be root 8. And I don't know that side or that side. I'm trying to make it into, I'm trying to use Pythagoras hopefully. And then I can find out what that one side here is. So root 32 is this whole side. So if I just look at that one side, I have root 32 equals x plus root 8 plus x. So root 32 equals, so be 2x plus root 8, square root of root 32. And I'm going to try to write these with some exponents. Maybe it'll be easier to figure it out. 4 root 2. I have like radicals. That's nice. I'm going to subtract 2 root 2 from both sides. Divide 2 by both sides. And now I know the side of that little triangle, the bottom. So this here is root 2. Now I can use Pythagoras. So one side is root 8. The other side is root 2. And my hypotenuse, I'm going to call h. So my hypotenuse is root 10. So this is root 10. And this side is the same because that's what that little line means. So root 10. Let's do our perimeter now. So my perimeter equals root 8 plus root 10 plus root 32 plus root 10. And I'm back to where I started. Square root of 8. 10 is 2 times 5. I don't think I can make that any simpler. All right, so like radicals, I have root 2's. Let's put our root 2's together. So 2 plus 4 is 6. And our root 10s. 1 plus 1 is 2. Our perimeter is 6 root 2 plus 2 root 10.